Okay. Okay. Thank you. Welcome to everybody. Today we are going to see a very nice program. It's called Streaming Shares World, and I would like to tell you before that there is we have a suite of more than 140 programs like this one, and this is quite unique. I don't know many software like this one, especially the Shareswell design, and I hope that you can appreciate that. It's very hard for this company to work, but the way they did a very hard job, on doing this and developing this software. Okay, so I'm gonna close or shut the camera because I'm not going to consume part of the transmission. If I continue with this camera, for sure I will have some transmission problems. So I'm going to disconnect it, and from now on you will see my screen fully. All right. Okay. So first of all, I want you to be sure that you must be registered in our BIMserver.center. I already create this project. It's called Chia's Walls over here, Chia's Wall. And beside that, inside the store, you have the programs. They are free right now for everyone. Doing so, it's possible for you to start working in this software. Another thing is that you have to use to start the building or the structure using the program CYPE. Also, you can ask the company for a trial, and then you can do the testing, things like that. All right. So we are going to start first with the program CYPE. We have a sequence of programs. The one we are going to use right now is going to be the CYPE. Then I'm going to move forward to the platform BIMserver.center. From the platform, I can use the Shareswell design, and later, if we have time, we are going to display the software Streaming Rebark. It's just for drawings. Just in case if you need it, you can use also the program which is called Layout. Layout is meant to develop or to upgrade or transfer special files. If you have some problem with them, you can use the uploader. You can also that kind of program arrange every file that could be corrupted, or maybe something is running inside the program, inside that file. Right. So suppose that we have in the BIMserver.center, you already have the program. Start, give it a name, and also you have several steps that you have to follow up. Things like the kind of project, the people that you are going to, maybe if you want to be the project open for everyone, if it's a professional one, and also they give you some permissions to certain people to see the program, to participate in the program, and also just to view it. Okay. When this thing is done, we can start using the program CYPE. Because we have only 1 hour, so I'm going to skip some part of this information, because it's gonna spend part of the time, and I don't want to make you wait for such a thing. Okay, I'm going to display around the 3D view. Okay, that's a 3D view. Of course, we have some key features here that allow you to see, visualize better in a better way what I want. This particular building have like this. You can appreciate more this view. We have a central core, which is belong several segments. For now, we are not going to call it walls. We are going to call it segments. But it's up to you. We can do whatever you want, but in certain way, I prefer to call it walls, shared walls. Once you are in shared walls, they like to use the name segments. So we have at the corner, we have 1 and 2 lateral walls, and in the center we have several walls for the lathe equipment. And the blue ones, these kind of blue ones, are the beams, which are the coupling beam. Sorry, the coupled beam has some particular requirements that we are going to talk later. And beside that, I'm going to show you as well some kind of features. Over here, you can control anything, and they give you on the right side, the top right side, extra information regarding to the one you are describing right now or choosing right now. Okay, so this is one thing. I'm going back, to the 3D view, but also in walls, you can display only the walls that are going to be part of your information later on in the program. Shares walls. It's only you can visualize here just the wall. If it's the wall are not labeled as shares walls, it doesn't appear here. Okay, so before that, if I display the walls, I'm going to edit one of them, for example this one, you will see on this side over here that you must describe it selected as a shares wall. That's one of the conditions, and the other one, you have to give it a label. That label has to be short. Make it short because I'm seeing problems, people describing a lot of information here, which is not possible right now. And also the entire wall, the thickness, and an extra reference, an extra feature that we are not going to talk now, but that's a very easy way. Okay, and this is it for the walls. But for the beams, we have something extra. Sorry. For the beams, we have 2 commands here, which is the automatic coupled beam. That give you a ratio. Normally, every code have a different approach. Some of them are giving different values here. Right now, what I'm using is the AC, and with this AC, they have this number is already set up for this normative. If you change the normative, for example, for the Mexican one, then this value is going to be around 3, roughly 3. And also, we have an extra information regarding to the beam. It says minimum depth that the beam has to be, and it's going to be 40 centimeters. But there are several cases that perhaps it's better not to do it as a coupled beam because there are very specific ones. I'll show you later certain cases that are not doesn't require to do it that way. Suppose you have a central core for the buildings, for the elevators, and that being are connected with the extreme of the walls. That being could be not possible, to describe it as a beam, a couple beam, because the you will see later that there are certain reinforcement that has to be displayed inside the walls, and that reinforcement in this particular case doesn't apply. And beside that, the ratio between the height and depth has to be in certain rate. Okay, so the second step is to define the couple beam. So the first one is the automatic assignment, and the second point is that if you display the second options, operate as a couple beam with diagonals. That's because in this case I have several beams who doesn't belong to this description. And the last part, if you have, for example, a lot of beams and you want to describe all of them without doing this process. So every time that you try to modify or to show to submit somebody else something, don't forget to not to click in assign, because this information are going to be applied for now on. So go to finish. Once the job is done and you run the analysis, this job I will take maybe 4 or 5 minutes to do it. So I'm saving that time for you. When it's done, you have to export this building to the BIMserver.center, which is our platform. And this, in order to do so, you have this button here, and now I did it. But if it's the first time that you are going to use it, it will display only a link. So once you click in the link, you are connected. And that's not the part that I'm going to skip because it's time consuming and I don't want to do it. Just to show you that you have to connect it with the BIMserver.center first to link this job with something in the BIMserver.center. And then when it's done, when the link is done, you can come back here and do the export. You have to do certain procedures step by step that are available for you, and in a very such a way which is so easy and straightforward. You have to follow the steps. It's just pretty simple. And then once this information is done, you can go to the BIMserver.center, and I'm going to close it. You go straight to the BIMserver.center, which is here. And I have this job over here. I'm going to use, I'm going to show the software. This is the platform. Right now, I am in the store manual, and you have extra information regarding to this software. And try to keep it in mind that you can come back here later and do some reviews. Over here, this is the download discharge available for you as well. And right now it's free, but later on maybe they are going to charge for that. Okay. Beside that, once the job is in the BIMserver.center in our platform, you will see this. Okay, so from now on, it's possible that you can open the software to your walls and can be connected with this modeling. One of the things that carry on from SciCAD is the stress. From CYPE is linked to the project in the BIMserver.center, and we export that. Okay, we already did that. Now from the share walls program, we create a new project. We give the name we want, anything you want. If we just say yes, for example, to import the BIM model, because it's always a BIM model, and also once this part is done, we can select the project, show that a drawing, because they're going to show you some kind of drawings. Then you can detect the shear walls and the couple beam. There are certain requirements once you start working with the program shear walls. Okay, so we already covered the CYPE program, then in BIMserver.center, and now I'm going to use the program shear wall. In shear walls, you have to create here in this menu a new project. Just give it any name. Okay, any name you want, and also we select the project, because in this case we have a project that we're going to link and show the drawing as we have only exported to the stresses, because that's what we are carry out from SciCAD. And then the software are going to detect the shear walls and the couple beam. Also the normative that we are going to apply, and also ductility, things like ductility and data needed to some checks. Okay, so these features over here, all these commands on the left side that I'm going to show you right now, you will see it later. I'm not going to spend time on that part. I'm going to skip that part. But to the top right side over here, I want to show you extra information that you must do it before carry on this software. It's about the units. You can click anywhere and you can modify these units. I know countries who use a combination of units, so be free to use it. Okay, this could be for the structure, for the element sections, for the reinforcement as well, and the analysis. And talking about the results, could be in kilonewtons or whatever is available for you, etc. Okay, so beside that, we have an extra information regarding to the drawings. The drawings, for the people who knows already the programs, site programs, is always the same routine. Right now, we are using this kind of model. It's a DIN 8 and A4. And also you have a configuration here for your own purpose. You can do any modification in the program and upgrade it if you want to, and depend on your necessities. All right, we continue. I think, okay, the last one, the undo and the redo. Make sure that this particular maximum number of action has to be 20. That's because I warn you that maybe you can lose part of the job, okay? Because by default, the program gives you just 5 times, but the maximum value is going to be 20. All right, after that, we go back here to the top left corner. We go back to the Word, the global. We have here the design code, this software. We started the job from SciCAD using the IC380, and if you click in this arrow, you can see all the normatives that are available for you right now. For people who are working in Malaysia and Singapore and Romania, Portugal, France, Spain, Bulgaria, and United States, it could be possible for you to work with this software. And also the 38014 and also the NTC, which is for Mexico. Later, I will show you that in some cases, well, in this particular case, I'm using the AC380, but there are some requirements that are more is restricted to the normative. If you are suppose you are using the Mexican code. In Mexican code, there are some very specific requirements regarding to the force amplifications. Okay, so if I already have the normative chosen from CYPE, if I'm working with the Mexican, I will display automatically here that's force amplification. All right, so we go back here for the design code. Also, you can control here the tension, shears, shear seismic, and shear coupling beam. These values are set up for you automatically. Go back to the kind of concrete types, and also you can create your own ones. You can create any one. The same thing for the steel, same thing. And then for the rebar, before, once you are opening a new job, you are doing once you are exporting, when you are doing the exportation of this software from CYPE to the BIMserver.center, they will display you this option, the reinforcements layout criteria. But I recommend you not to do any modification over there. It just is a table that are giving you, but for sure, once you are in the software, you can display and do the modifications as you need. Could be for the unconfined reinforcements and confined reinforcements. There are several options. For example, if you are using the Eurocode, for sure, by default, the selections of these reinforcements are completely different. All right. On the bottom over here, you have confined complete segments. There is a formula here that you must apply to these reinforcements, and this icon, you will see an extra information confined regarding to the confined complete segments. This ratio also has to be verified sometimes. And well, that's all for this. And I'm going to move forward. This is for the shears walls, but once we move to the coupled beam, which is right here, you will be able to display the reinforcements about the coupled beam as well. Okay. So we cancel here, and then the next anchorage options. There are several ones for the horizontal reinforcements, for the vertical reinforcements. It's up to you. All right. And finally, the representation options. The add is an abbreviation for separation between bars. They do it by default. And properties are regarding to the concrete, the horizontal reinforcements, the vertical and geometric cover, and also seismic reinforcements criteria. Anytime you see that kind of screen, is a kind of grid, you can display that grid, allow you to bring something from another source. Could be your library, could be somebody's library. Also, if you want to save it for later, Maybe you can save it in this software, in this computer, and then you can download it in another computer. It's kind of library options. Anytime you see this kind of pencil, display the pencil, and this you are editing regarding to your selection here. Anything that you select here. Okay, that's all for this part. About the interface, I think it's done. Remember that that we are carry on from the software sidecut are the stress. Okay. So once you are in the software, perhaps you haven't done the analysis. So you have three options here. You can do the designs all walls. You can design just one wall, or to design a span, right? Well, sometimes it's possible that some of the options, some walls are not done fully. So you have to go back and do some kind of extra modifications to perhaps here change this value, the confined complete segments. That's the first thing that I should do. Instead of doing something else, I prefer to do this before. What else? Well, this is it for this part. I'm going to the couple beams. We go back here to the reinforcement. Remember, in the one before, I had the option just for the shear walls, but now we have for the couple beam. Same thing for this. But the options, the dimensions over here, the dimensions, the minimum width of the diagonal elements is different, of course, but that's the first thing that I advise you to modify it or upgrade a little bit. By default, could be a value of 0.5, but you can split that for 0.6 and so on until you fulfill the requirements, and finally the reinforcements appear and the program do the combinations as well. Okay, going back to the charge walls. All right. Okay, so before doing anything, I'm going to display the 3D view. It's going to take a little while, but I know it's a lot of information. Carry on. And don't be desperate. It's going to be okay. Okay, won't be long. So as a summary, it's important to note that for some standards, the seismic checks are for ductile walls. Okay, and now after watching this 3D view, I will show you kind of the checks that the software does, and also it's very important to know what is doing the software inside. In order to do so, I need to display this option, the 3D view, because there is something very important inside the software that you might know from now on. All right, it's almost done. I'm sorry to keep you waiting. Okay, so we have kind of normative the error code in fully in 9.6, 8.2, 6.3, and also we have the error code 8, error code 2, error code 8. Also the NTC Mexico 7.4, 8.4, 9.4, the IC 38011 version 21.4, 21.9. In the last one, the IC 31814. Okay. Well, the user can give directly this to sites, and if all the import has been correct, we can either continue to check walls or get information for the listings. The listings are very unique, it's quite neat, and I'll show you it also later. What the program does is an integration of the find elements to create the total efforts. These efforts are used to check anomaly stress, and then there are the effort by segment. They can consult in the effort icons, which I'm going to do it later. Okay, it's almost done. Okay, good. Now it's coming. Now you will see why it takes so long. You know the connections between the BIMserver.center and this software is very accurate. It's faster, but sometimes take a while. And when I did a test, it wasn't like this. Perhaps there is a lot of traffic right now working on it, and take a little while. Okay, what can I tell you? Okay, good. It's coming. I'm sorry, guys, for the delay. Good. Finally. Okay, if you notice, I'm doing very slowly but surely because of all this. Also, there have some delayed between the voice, my voice, the sounds, and the view itself. Okay, so if I turn it a little bit, you will see some colors inside. Okay, that kind of colors are, I call it bulb. I'm going inside. I'm going inside here. That kind of bulb, you see that bulb is almost in the center, but if you take in consideration the three walls who are around, who belong to that cord, the program itself are doing this bulb, and inside the bulb you got an extra information, which is the reference. That kind of reference is what we call that's what we call the science criteria. Okay, and I'm getting now. So once you are inside, you will see exactly different points. Right now, I'm going to click. Oh, sorry. you have to be careful. And then click this consulting information of the elements, the icon. And if you click in one of the points that are here, right, you will see the failure forces were around the valve. But if you go closer inside, you have a zoom in, can do zoom in. Now I am inside the valve. Okay, I'm getting inside and try to touch one of those bubbles over here. Once you touch one of the bubbles, you will see on the right side, top right side, you will see extra information regarding to that properties. Could be the forces, the axles, and moments in X and moments in Y, and also the values. Okay, all these things are doing the software for you. It's a lot of calculation. As you can also remark that there are 3 walls over here, but uh, this bulb is almost in the center. Take in consideration the 3 bolts and exactly the center. Okay, it's the same. The resistance sections here, you can displace anything you want, especially the coupled pins on the walls. I think this is it for this part. I'm gonna close it. I'm sorry, guys, for the delay. And um, and then I'm going to show you here. I'm going to move a little bit, something like this one. Give me 1 second. What I'm trying to tell you is that that bulb that you saw already is almost this situation, is the third one. Okay, the effort that we're bringing from CYPE, the effort, and also transferred here in 3 segments, because we have 3 segments, and this bulb over here is the one I'll show you. Yeah, that's are used for checking the normal stress, and if we are just showing just one segment at a time, you can also use it to obtain from total effort, and they are used for checking share. All right. Okay, that's it. So when the program is done, you can come back here and check the before that I will show you the forces. The forces, you can view all of them. Right now I am choosing just the segment SW1. I am on top of the floor. It's a force story building 13, and on top what I'm seeing here right now is these values on top, and the bottom over here, that's the total height of the wall. You can display in any point the regarding forces. The table forces over here, it's possible for you to see on top, on the base, the amount of information that the software is doing for you. I'm just thinking that if we want to do it by hand, it's gonna cost you a lot of time, to do it by hand. It's time consuming, and it's a lot of work. I'm going to display everything that all these kind of calculations the software are doing for you. Very tough, to do it by hand, and perhaps you really appreciate that. It's really important to know that the amount of calculation and time consuming here are really very unique. That's why this software is one of the kind in the market right now. Okay, I'll be close here. There are now certain points that I want to be clear, which is the segment classifications. Remember that I always trying to tell you things about to give it a different name. Inside CAD we call it walls, but here now we are going to see it differently, to call it different. On top we have this wall because I show you on this screen right here that the walls on top doesn't require 3 sections. You see over here doesn't require 3 sections. There is in this floor, in this particular floor, there are 3 sections. This is 1, this is 2, and this is 3. But on top, from that part on top, it's just 1 section. So that's why if you display the segment here, you have on top just 1 section. If you go down, maybe the story 1, floor 1, you have 3 sections. Okay, now there is something that I want to not pay attention what I'm trying to say right now because it's a little complicated to explain, but I'm going to do my best. Okay, remember that let us remember that from CyCAD we export the forces, and these are combined to give the result of the bending and shear forces. This resultant, which is a vector, finally falls into one of the forces zone. This forces zone could be this one, this one, this one, and this one. This is the 4 zones. And also the results, these results falls in one of the 4 zones and to be classified as web or flange. It's funny, but if you translate this in Spanish, web goes for ala, and flange goes for soul. It's called wing and soul. It's quite I prefer, to use the word in Spanish. I know it's my language, my native language, but for me it's quite different, very different from the English translation. So anyhow, web go for the winds and flange for the soul, right? So this resultant, this vector happen to be in one of these zones. Depending on that zones, we call it differently. And suppose in the first, suppose we are going to see right now the reference S1, which is the segment 1. If the segment 1s, according to this area, which is alpha 1, the wall, which is this one, is called web. If we move on to the same area, alpha 2, according to that, the wall 3 we call flange, and so on, right? The only case that the segment is always a web is when it's single. When it's single, you will see it like that. Okay. What is really important to notice is that we must clarify which part of the segment are be effective zone and which not, and which doesn't. And because after that, we're going to have the effective reinforcement. That's why we must do this first. But you don't have to worry about it because the software are doing it for you. And also, if you want to change or study a different case, you can change this value, the end value, or give it a different number. And after that, when you accept, the program are going to do a different combination. That combinations are, if these combinations, remember that we already have certain combinations regarding to the factors that we already set up in the software. So if these modifications affect some part of the combination that we already have, the program are going to update the informations and change the values of some of the combination that we already had. All right. Okay, I think this is it. Remember that it's better to understand that part. It's always an option to change it anyhow. All right, so we go back, I'm going to close this a little bit. Now, if we want to check the reinforcements, you must click here and edit all of them. This is the reinforcements for this case. I am in the top level. I want you, to work on it. If you go back, to the first floor and can display the reinforcements, you will see a different background because in some of the zones according to the segments are effective or they are effective zones, so they are going to apply these border element, edge elements, which are very specific reinforcements. Now we can display here in the normative loading on the bottom. But if you click in this button, the pencil, what are you going to see right now is the one of the most important things. Of course, everything is important, but this part, the normal loading, is quite unique. Okay, so the effective zone are the color green over here, color green over here, effective zone. The program knows right now that the reinforcements over here are going to be different than the other ones. In this case, this part are going to be called, it depend on the location of these segments, are going to call a width or flange, right? So now we can show and edit the panel. On the right side, on the bottom, so we can see the equilibrium diagram. The one on top, which is yellow color, means that there are effective zones and there are different reinforcements. Also, you can display the normal loading. It's a document who describe everything according to the normative. If you travel around this, that's the ball, almost the ball that I was showing you in the 3D view, right? We go, you go back, yeah, something like that. This is the worst case force balance of this section. It's pretty cool, to get this, and you can present this extra document to one of the places that you might require. Okay, in this table, suppose you want to verify something in particular. You can change the backlink, or here in the backlink atmosphere, you can check the embrace lane, for example, for different value, and also you can check also the effective lane forces. And after that, if you accept it, that information are going to change the values. But if you are familiar with the software CYPE, you will see that once you displace the columns editions, also the beams editions, there are certain features that you can modify in the program, but also when it's done, you can save that information, because in the future, if for sure, and we will have some kind of modification. Could be minor modification, but if you run the analysis, the information are going to change. That's why in the columns and the bins, you have that feature to save the information. In this case, it's important to notice that we don't have that lock. We don't have that lock, but be aware that if you do it, it's because you want to do some kind of studies or something in particular. Okay. We move forward. This is about the segments over here on the bottom, the segments. Then we go for the shear, that checking the shears. This is the ratio that I was telling you before. We go for the initial edge elements and the final edge elements. Okay, this quadrant here over here doesn't show anything, but if you see this check, the green check in the column, means that that segment require extra reinforcement or special reinforcements. And okay, on the last part, you go back here, clicking the button. You will display the checking. As you can see, you can travel in and verify all these code checks, according to the normative. If you are using the Eurocode, you can use the Mexican ones, and we are upgrading the software. Later on you will have more normative, but at the moment we start with the AC380, and now we apply the error code and so on and so on. Also, you can click here in this button on top left, click there, and it's almost similar to the other one. And also you can describe a different material and change it and accept it, and everything is going to start all over again. On top, you have a view of a complete listing. It's almost like this. It's pretty neat. This is the AC380. This is the shear strength. If it's also okay or not will be displayed in this color green. If it's not, if it's something wrong, you will get it a different color, could be red, kind of red. All right. This information also, you can export that to any of these formats. You can display that to export that to PDF format, or XML Office Open, anything you want here, and also to Excel. I think this is it for this part. And the last document, which is over here, you click here, it's the same description. It's pretty neat, pretty useful, and the same thing. The last part that I want to show you, I want to move here a little bit. The reinforcement that you're getting here, different color, different bars, different reinforcements. Once you have it done, you will display this in another software, which is called Stubin Rebar. In Stubin Rebar, there is not, well, I always refer to the original software, which is the CYPE, Site3D, because they have a very nice and unique displacements of the reinforcement. And also, you can also edit that reinforcement, you can change that reinforcements and send them to another CAD program. If you need to upgrade something, you have to do it in AutoCAD. But that's the way inside CAD and 3D. In this software, the only thing that you have is just that view that you are seeing right now. And that view, it's kind of GPG files. You can also show your clients details about how going to display their reinforcement. And well, that's it for this part. Okay. On one on top right, you have the upgrade button. The update button, suppose you are working with this job and your colleague are doing some modification in the original program, which is CYPE. So what he's doing right now is affecting your program, your structure right now. So if they can call you and say, well, you have to, yeah, I did some modifications and be aware of that. So you can click here and update button, and the modifications are going to upgrade here. Could be the geometry, the effort, and also the stresses. Okay. What else? Okay, we go back now, but that is important to show you the forces amplification. The choice amplifications are very important. For some standard, have a stress amplification criteria, as I told you. Okay, the amplification of moment consists of vertical displacements of the law of bending moments. We need to find out this amplification. If you click here, right now it's not available because I'm using the IC code. But if I'm using the Mexican one, I will have everything here like this with the original values by default, right? So if I click in this icon, you can just to show you an idea what really means. This part is that's the total height of the wall. That's the law of moment. The h delta h over here in the left side, that's the value that you have to find. And then with this value, you go, but you have to trust, you have to draw lines, a segment line over here to join the top of the wall. And then with this line, you can, parallel to this one, you can get the second point. Okay, that's the way to visualize this graphic. And for the second axial force amplification, but this is something which is the way I see it. For example, I'm going to change this for 1.2. Oops, sorry. I did something wrong. Sorry. 1 point. Suppose I'm going to change for 1.2. What this really means, the amplification of axles. If I give it a value of KP of 1.2, what it does is it multiplies me with 1.2 and with as well as with a 0.8. I mean, it amplified me 20% more and 20% less. All right. Okay, so the last part, the cheers wall. Sorry, let me drink a little bit. Sorry, guys. Okay, so we go for the shear force amplification. In shear force amplifications, I'm going to help myself with this. Okay, we have a different coefficients. It's K0 coefficients and KH coefficient. We have the same thing, the total height of the wall. From the lower side, we have the shear stress, the shear force, and then we multiply from some factor, from key factor, to order to get the shear, the new shear, which is here. The H1 and in some normative R is 1/3 of the total height of the building of the wall. So with this new value on the bottom, and with the 1/3 of the total height, we get this point, the second point. And from this point, we have to join, because the one on top is something that we must get it as well. We must find out this value on top. So we can join this point, and this is the segment that show you the amplification for this part, for the shear force amplification. Okay, I think this is it on this part. The layout, let it brazen, but it's not, well, just if you want to change it, we already did the segments, properties, so we move forward to the couple beam. For the couple beam, we have almost the same thing. I'm not going to explain the interface, as that's almost the same, but I'm going to display it just for for this case. Let me check. It's going to be like this. The reinforcements are different. You see on the right side. Well, okay, good. You know, these reinforcements, if I move forward a little bit and try to show you the values that already have. Remember that when we were going back to the CYPE in beam selections, remember that we have these options, the automatic couple beam. This value, this range, has to be consistent in order to get the definition of couple beam. And also the second step, we define the couple beam, has to be, well, you have to be careful, doing it. And what is important here is that about the reinforcements, that we already have an extra feature according to the couple beam definition for perimeter reinforcements and diagonal reinforcement. Remember that part over here, that these values, this value over here, you can change it. You can change that value if something is wrong in the analysis. On the bottom, we have the same information regarding to that beam. You can edit over here all the calculations done for that beam. I think this is a couple beam that requires to place our diagonal reinforcements according to that normative, the perimeter reinforcements, the layout, and so on and so on. Okay, kind of diagonal, and also you can click here to show and edit part of the information. Okay, good. I think this is it. Um, and beside that, well, you can design all the beams, design the group of beams, and design one of the beams. The same environment, almost the same environment. This is the ratio on the bottom for the shears. And this is the ratio for the size of the beam. Remember that not always have to fulfill the requirements in order to describe or define the beam as a coupling beam. All right, okay, so, well, right now I have something to show you. As a resume, I can start showing you the workflow for the charts. This is the last versions, the 2021 version E. You can get it from our BIMserver.center. This is the original files in CYPE, the chairs walls in color, different colors, how to describe it as a chairs walls, and the bottom how to export that into the BIM environment. And we go forward. That kind of check the user can give directly to size, and if all the export, all the import has been correct, we can either continue to check walls or get information from the listing. Okay, we go continue. That's the information that we already have according to the original files inside CAP. In the total effort is what we are looking for. This is the how to describe the effective sum and not effective sum. Remember that you don't have to worry about it because the program does it for you. This is the moment amplification and also the axial force amplification. The data for amplification charge stress are automatically generated in the import. Also kind of, more information regarding to that analysis and so on and so on. Oh, this is important because it's the special boundary element, which is telling you that over here, is telling you that that segment needs a special reinforcement. And now we go for the couple beam. It gives you exactly how strong the reinforcements are in this kind of coupling beam. And okay, so we must define the ratio according to this value, the height and length and depth. The ratio defined whether or not it requires diagonal reinforcement. And also this ratio, if that is greater than the limit value, we go for the conventional reinforcement, which is on one and top. And if the ratio is less or equal from the limit value, we go for diagonal reinforcements like this one. Okay. That's kind of a well, I'm just showing you that you can display the sharing's reinforcements and also the length which is inside the walls. Suppose this is the limit. This is the limit. Go from this side to this side. This is the limit of the beam. But the reinforcements are getting deep in the walls. Okay. Extra information. What is important here to see is that the limits state of well, you call it exhaustion, but I don't think it's the right word, occur at the end of the beam. Suppose you have an horizontal load, and that horizontal load are going to move a little bit this building, but the connection between walls are the beam, right? So that beam is meant to verify the stress force over there. The details of the stress force is done over there, and that's why we have to define this shear force, and to verify the force in different areas. You have for the reinforcement, and we do it with this formula. Okay, I know that different normative that are different formulation, but it's almost the same criteria. Some of the same criteria. The most important thing is this direction. The beam all is the mean. Well, if you have a normal building and for the normal load that they are carrying on the building are the gravity forces. But once you apply the horizontal force, doesn't have any. You have to define tension, torsion, shear deflection, everything. But in this case in particular, what you mean to take in consideration is just this shear force, because it's more important than shear force than anything else. Beside that, I think this is it. Thank you guys for your attention. Remember that if you have any questions, just use the technical support department. We are very helpful and ready to get in contact with you. This is it, guys. If you need something else, just let me know, and we continue with this kind of seminars every week. Any questions up to now, guys? Okay, guys, thank you very much. I don't see many questions up to now. Thank you for your attention. Thank you for being here. Enjoy your holidays and be safe. Thank you. Bye-bye.